Alright, so this is lesson 12 of Python for data analysis. We're going to go to the GitHub page, click on Lessons, Lesson 12, and click on that raw link so we can download the notebook file itself. Go to our Lessons folder, and then download that file using curl. There's another command called wget, which you can use if you have a Linux system. It doesn't come with Mac by default, so we're using curl. And then we're going to activate the Python 3 environment, and then Jupyter Notebook. And click on Lesson 12. Alright, so this is Pandas Part 2. And the readings for today are listed here. That's it's chapters 6, 7, and 8 of McKinney's Python for data analysis book. So those chapters cover data loading, storage, and file formats, data cleaning and preparation, and data wrangling, join, combine, and reshape. So we'll touch on those topics, but in a slightly different order. So there's a list of topics we're going to cover today, and those are linked to their spot in the notebook. So if you click on that, it'll take you down to that link. And the way this works actually is you can see this if you double click. You can see those links there. There's the link in the text is in brackets, in square brackets, and then in parentheses is this hashtag tag. And then if you look at the it would be in here. If you look in here, there's this HTML tag with says ID equals, and that's how the hyperlinks work. Okay, so first of all, we're going to need Pandas and Numpy, so we'll import those. If you get an error, let me know. That should work for everybody. And so last time we talked about Pandas data frames and some of the operations you can use with those. Today we're going to go a step further and learn some more advanced things you can do with data frames. So one of the really nice things about Pandas is how it handles merging, joining, concatenating data frames in really sophisticated ways. So imagine you have two tables that have the same set of IDs. Let's say you have a table of observations about your environment, and then you have another table that has metadata about those samples. So you have the actual data, observational data, and then you have the metadata. And you want to combine those into one table. So what Pandas can do is you can say you have the sample names as your index columns. You can then go row by row and match up those indexes and merge those two tables intelligently. And you can then say, I only want to keep those, I want my new table only to have those IDs that were matched between each one. So if there's no match, remove those. Or I only want to keep ones that were in the metadata table, but if they don't have a, match in the data table, that's fine, but if they're only in the data table, then I don't keep those, for example. Or you can have, I want to keep everything, that kind of thing. You have a lot of control over that. So that would be a merge operation. You can also concatenate, which is a more basic, just take two tables and sandwich them together. So a lot of stuff you can do, and we'll see how that works. So the concatenate and merge are kind of two ideas. So concatenate is just like we've seen before, is where you take two things and just stick them together. Typically, you'd have like two tables that have the same columns in the same order, and you just want to combine them. And then merging would be where you have two different kinds of tables, but they have some columns in common. Say the IDs, or it can be one of the data columns too. You can merge on that. So those would be pd.concat and pd.merge, and then you have two data frames here.
And there's a typo. Hang on a second. I want to make sure I got the syntax right here. Yeah, I think this one actually takes a list, not a. They're a little different. So this one takes a list of 2 data frames, and we'll cover all this. I just wanted to make sure my header is right here. So there's two ways to do this. So in Python generally, and in Pandas specifically, you can have a Pandas function, and then it takes like 2 data frames as its arguments. Or you could have one data frame object, and then it takes the other data frame as its object, or as its argument. So that would be the append and join methods are analogous to concat and merge. So concat is where you take 2 data frames and you concatenate them. Append is where you take 1 data frame and you append the other one. It's the same thing that's happening, but the logic is different. Depending on how you like to think about things or how your code is constructed, you would use one or the other. Same thing with merge. Typically we'll use merge, but you also have this option to join one to the other, and it's doing the same idea. So, so there's some information here about concat and the various arguments it takes. The main one is the objects that you're passing, and typically it'll be a list of things you want to concatenate. The reason that concatenate takes a list of objects and merge takes just one and then the second one is that it's possible to concatenate 3, 4, 5, 6 data frames all together, right? But it's not possible to merge more than 2 things, because then you get into conflicts of like which, how are you going to merge 3 things together. It's much more straightforward to merge 2 tables, just merge 2 tables. If you want to merge a third one, you can merge 2 and then merge the third one after that. So that's why these have different syntax. There's a lot more stuff that we'll see here below. There's no point in going through it in detail now, but it's here for your reference. So what we're going to do to illustrate these tools is we're going to create some data frames to test with. So these are data frames that are constructed from dictionaries. So this is this df1 is going to have these columns and these rows, and these will be the indexes, and so forth. So we'll see these in a minute. So this is, and sorry, I keep forgetting to. Let's go ahead and restart and clear output. And then we can go down to the cell here, df1, and say run all above. So this is going to run everything. We just wanted to clear that output, and this will refresh everything too. So now we're up to cell 2. You can see that one's been executed because there's a number 2 there. So now we'll all be working together. Okay, so we've got our data frame 1 here, data frame 2, and data frame 3. So these are just examples. You have the rows and the columns are indicated by the values, so you can easily see where things are coming from. So first thing we're going to do is concatenate those 3 data frames. So we're gonna have a list of the data frames. We could do this all in one line, but here we're separating them out. We're gonna have a list of the 3 data frames. We're gonna use the pd.concat on those data frames, and we're gonna get this result. So by default, it concatenates them. It assumes they have the same columns but different indexes, right? This is a common example. You've got lots of different data frames. They all have the same kinds of data, but there's different observations. So the columns would be the same, but the indexes would be different. So that by default, concatenate sandwiches the tables vertically. If we want to add a hierarchical index, we can use this keys option. So now each of these data frames has a secondary index on the left here, and that allows us to do something like this, where we can pull out just part of the data frame. So now we're going to make a fourth data frame, and this is going to have different columns. It's going to have some columns that are the same, B and D, but it's going to have a new column F. So if we look at, that's DF4, and then we have DF1 here. Now we're going to concatenate those. Okay. We're getting a warning about something that will change in the future, but we'll not worry about that for now. So what happens when we concatenate these two data frames? By default, the axis is 0. That means we're just stacking these things on top of each other. So what happens is we get NaN values where there's nothing available. So this first data frame has columns A, B, C, and D, and the second data frame had columns B, D, and F. So if there's nothing to fill there, it will just fill with NaN. And we can see later how you can fill those if you want to fill them with like an empty string instead, or fill them with some value. So if we had done pd.concat axis equals 1, this is, so axis 0 is vertically, axis 1 would be horizontally. So we're merging on, or another way to think of it is axis equals 0 is merging or concatenating using the columns as the common identifiers, and axis equals 1 is concatenating using the indexes as the common identifiers. So here, if we go back and look at 4 and 1, we see that 1 has indexes 0, 1, 2, 3, and DF4 has indexes 2, 3, 6, 7. So the only indexes that are common between these two are 2 and 3. So if we go down and see that, we see that indeed 2 and 3, rows 2 and 3, or indexes 2 and 3, have values across both rows. But for 0 and 1 and 6 and 7, we just have nans. So this is how pandas will handle concatenating if you have missing data. Another way to do this is by default we have this join parameter that is by default set to outer, but we can also say inner, and in this case it will only give us the common, in this case it's axis equals 1, so it will only give us the rows that are found in both data frames. Another thing we can do is ignore the index so that, let me see where that other one was. So that let's have a look because I'm not seeing any difference here. Yeah, so if the indexes were not, this will basically reset the indexes to just start at 0 and go up to however big the data frame is. So we'll kind of reset the index. All right. Another thing we can do is we can have 3 series, and we can concatenate those series to make a data frame. So remember, a series is like a column in a data frame. It's analogous to a NumPy array or a list. And so each series can either have no name, or we can specify a name, and then which is analogous to the column header. So that will be the column header once we concatenate those. And in this case, since we want those those columns, those series to be columns, we're going to set axis equals 1. This is another example where we can say we're going to have we're going to specify these keys as will be the names of the columns. So append is so that's concat. Append is very similar, except instead of saying concat, this set of data frames, you're going to say I want to take one data frame and append one or more data frames to that. So it just kind of changes the syntax a little bit. So we can take df1 and append df2, and by default axis equals 0, so these will get put on top of each other. And so in this case, what it's telling us here is this is a warning. It's not an error. So a warning says, hey, you should be aware of this thing for such and such a reason. It's still going to work, but in this case, it's a future warning. So it says, in the future, the behavior will change. So what it did was it sorted the rows because there was some misalignment they didn't match up, but in the future it won't sort by default. So just to warn you that. And so if we want to say to accept future behavior, we can set sort equals false. So we can go ahead and do that. And notice how this word false is in bold green because the notebook knows that's a special word. That's a Boolean value. So now we can see that we actually had let's see what we had before, and we can compare. Oh, sorry, I did the wrong one. Whoops. Okay, I changed the wrong cell. So we want df1, df2, I think. Oh, okay. I'm not getting. I can't get the warning anymore. Anyway. So yeah, it'll just change the way whether things are sorted or not. Okay, so that's concat. That one's nice for concatenating data frames that have similar columns. Merging is even more powerful because it will go ahead and look at the identifiers in your data. Doesn't just look at to try to combine similar column and row names. It actually looks at the values and will merge the data into a single data frame. So it should have a data frame that should have maybe just adding one more column or a couple more columns to your existing data frame. So there's all this information here you can use to kind of refer to as a reference. But let's go ahead and test this out. So we're gonna make two data frames that we're going to call left and right, and you'll see why in a minute. And these are going to have just the basic numerical index. We're going to have a column called key, which we're going to use to merge on, and then we're going to have additional columns A, B, C, and D that have some kind of data in them. So the first thing we're going to do is we're going to do a pd.merge on left and right. So since merge only works on two data frames, these are typically used as positional arguments. So you don't have to use the keyword. The keywords are left and right, but you don't have to use those because you can just say, what is the first one, what's the second one, in order, and then on is set to key. So this is going to use this column key that's found in both data frames. Important that it has to be found in both data frames to merge those. So now we see we had key 0, 1, 2, 3, and 0, 1, 2, 3 there. And in this case, they're in reverse order. So we're going to have A, B, C, and D. We'll see there those the rows in this case, the rows are in the same order that they were in the left data frame, and then the one in right, the row orders got inverted because of where the those keys were. So we're left now with one data frame with one column key that corresponds to those original values, but now we're merged into a single data frame. So we're going to do another example where we have multiple keys, so we can merge on multiple things. So here we have key 1, key 2, key 1, key 2, and we're going to, what this is going to do is it's going to look for unique pairs of these two columns. So the two values for key 1 and key 2 have to be the same between the two data frames. And so by default, we're only going to get the rows in the two data frames where the keys are the same. So we have K0, K0 here. So this would be row 0 from left and row 0 from right. And then we have K1, K0, and K1, K0. So this would be row 2 from left and row 1 from right, and again row 2 from left and row 2 from right. So we're getting this we're getting A2 and B2 in both rows because those were matched, and there were two possible permutations there. So by default, the merge method is inner. This gives us only the intersection of the keys from the frames, but if you want just the keys that are found in the left frame or just the keys that are found in the right frame, you can set how it's the parameter is called how. I should change this. So the parameter is called how, and this tells you how to how you're going to merge these, either on the inner, which is the default, or on left or right, or outer, which gives you any key that's found in either data frame. So for example, if we set how equals left on key 1 and 2, we're going to get all the key combinations from the left data frame and any of those matched up with any that match on the right. Similarly, we can set on right, and we're going to get just the keys that are found in the right and any of their matches in the left data frame. Or we can have outer, which gives us all the different key combinations in both data frames, or the inner, which is just the default behavior. There's also this thing called a merge indicator. So I'll show you how this works. Here we have these two data frames which have these sets of values, and we can set an indicator that will have this column name merge. You can call it whatever you want, and it will tell you which of those data frames was included in the merge for each row. So left only, both, right only, right only. There's another. Let me just search. There's another. Let me see if I have this in here. Okay. So we're going to see another example that's really useful later. So we'll come back to this. Oftentimes, when you merge, and so a couple of things here. One is that typically we don't put the left equals and right equals. These would be the keyword using the keyword type parameter, where you say the keyword equals the thing that's going to go there. But Python also supports positional arguments. So if you don't put left equals and right equals, if you just put the name of the data frame in the order, it knows that you meant that the first one was left and the second one was right. Once you start putting, if your third argument has a keyword argument, then you have to use keyword arguments for the rest of the command. But the main thing I wanted to point out, and we'll come back to this example, but I wanted to make sure I mentioned it, is that oftentimes the most common merge thing you would do is, in my experience, is you have two data frames with the index has the key that you want to use, the index being the row name. You want to merge those two based on their indexes. So the way you do that is, instead of saying key equals, you say left index equals true, right index equals true. Or there's different ways to merge. You can also say left on equals and right on equals. So that's a case where the key is different between the two data frames. If the column name is not the same, you wouldn't say key equals. You could say left on equals key 1 and right on equals key 2, and it would know those are the columns you want to compare. But if the columns you want to compare are the indexes, you say left index equals true and right index equals true. And of course, you can get all this information from pd.merge ? And it will give you left on, it says all this stuff. So there's different ways to specify how you want to merge. Again, I'll come back to that. So similarly to where it has concat has whereas concat has append, merge has join as its sort of analogous method. So if we have left and right like this, we can say we can start with left. It has this method join, which is to merge in another data frame. So it works the same way, but the first one that we mentioned is the left data frame, no matter what it's. This is what the data frame is called. So it works the same way, but it's just the order is specified by whatever is the thing that is merging. It takes the same kind of arguments in how you join with inner and outer. And if you have overlapping column names that you're not joining on, so typically if you have two data frames with the same column name, you might be using that to join those two data frames. But you might have two data frames that you're merging that have the same column name and you're not merging on those. And so how are you going to know which data frame that column came from? Did it come from the left data frame or the right one? So what Pandas will do, here you have these columns K and V. So K is like the key and V is the value. We're going to merge on the key, and then the value, we have two columns V that are in here. So what it's going to do is it's just going to use X for the left and Y for the right. So it's going to be V underscore X and V underscore Y. If you see that, that means you had columns that had the same name in your merging data frames, and you needed it needed to somehow differentiate those for you. Now, if you want to have more control, you can supply this argument suffixes, which will set the name, which will set those suffixes that are used. So in this case, it'll use underscore L and underscore R instead of X and Y. So here's an example. Again, let's say you have some genetic data with counts, and then you have some metadata describing those. So here you have these 3 genes where you have data, and then you have names for those genes in another table, right? You have the annotations for those genes. So if you did a merge on those, you could now have your counts table with the descriptions right next to them. So it's very handy to see what your data is, and oftentimes those would be in different files when you start out. So this is giving us the same output, but you notice we didn't pass any arguments. So by default, it merges on whatever column is common between those two. So it figured out. But typically, you'd maybe want to be explicit, just so there's nothing in doubt. And again, by default, it's merging the inner columns, which is the columns that are only the things that match up between the two data frames. Question?
What will happen if the key values from the two data frames are like they have the same value by different type? Let's say one is a date time and the other is a string, but the value itself it's the same.
Good question. So the question is, what happens if you merge? So if you're concatenating, so when you're merging, unless you're using those as the keys, what you're merging, they would remain separate columns, because.
Oh. Yeah.
But if they had the same name, concatenating, they would be concatenated into the same column, and then I think the data type would change to object.
It will force it?
I think it would force it to change. If your keys are different types, I'm not sure. It might try to force it also. It would be a tricky situation. You probably want to avoid that. I'm not sure exactly what behavior it would have. Mm-hmm. And okay, yeah. So this is the example I wanted to mention. So let's say you had, again, you have two tables, one with genes and one with count. So what I did here was something kind of sloppy, but I just copied the gene column to the index. So here we had the index is just numerical. Here I'm saying I want the gene column to be the index as well. So I'm going to get this gene is mentioned twice in both data frames. But the reason I did that was so that I could show this example where we're going to merge on the index instead of on any other column. So we say left index equals true, right index equals true, and now we are going to have these. So actually, what I can do is do. Let's see. Okay, yeah. So here's what I'm doing. I'll delete this first. So I'm saying I'm going to set the index. I'm going to set the index as a column that I have of my data, and then I'm going to delete that column because now I have that information as the index. So it's a way to like get that information that's in one of your columns and make it your index, because it's really useful when you're merging. You don't have to worry about which column. You just merge on the indexes, and your life is easy. So what I do is I'm going to say in place equals true, so that will be stored, and then I can see there, and I'm going to do the same thing here. I'm going to drop that column gene because it's been already made to my index. Axis is 1 because it's a column name, not a row name. The axis, it's not always row, yeah, you kind of got to, I always have to just try one or the other, and eventually I get it right. It's like a USB stick, half the time you're right. Dropping that gene column because I already made it my index, and then I'm doing that in place equals true, so that will be stored as the data frame. And so now when I do this merge, I don't have those extra gene columns that are ugly. So now I've got what I want, and I merge by index. So I think for me that's a common way to do it.